Hello and welcome to helpyourmath.com. In this video, we are going to look at the fundamentals of probability. Since this is the introduction, we will be going over some definitions. I am fascinated by probability and I hope you enjoy it as much as I do. So what is probability? Probability is the likelihood that an event will occur. This can be expressed as a decimal, fraction in simplest form, or a percent, and really all three ways are used interchangeably, especially depending on what course you're in. In statistics, they use a lot of decimals. In, a lot of places we see percents and very frequently we also see fractions. So all three of these are solid ways to express a probability. The notation for probability, we say P of the event. So this is a function notation. If you've taken an algebra course, the P means percent of, and then inside the parentheses, we somehow label the event. We usually use a capital letter, but if we need to, you can write a whole word. So if the choices are brown, blue, black, where they all start with the letter B, you can't say the probability of B because that's ambiguous as to which B it is. You might write out the whole color, or maybe you would do BL. You can't even do BL because there's black and blue, which both start BL. So probably you would just write the whole word. But usually we try to abbreviate it as much as humanly possible. So again, just to reiterate, this stands for probability of. This is not multiplication, this is just a function notation. And then inside the parentheses, this is whatever event we're looking for, usually represented by a single capital letter, if possible. In this example, what is the probability of picking a red Skittle out of a bag of Skittles, and I should say an original bag, right, of original Skittles. So based on my research, there are 5 Skittle flavors in a bag of Skittles. And the colors are red, orange, green, purple, and yellow. Since they all start off with different letters, I can say the probability of R, and it's very clear I'm talking about the red Skittle. And then because there are 5 flavors, and we're going to talk about this in a later video, the types of probabilities, but going by the fact that there are 5 flavors, we're going to use that to say the chances that you pick a red Skittle are 1 in 5. That would be the fraction, or you would write the percent. There's a 20% chance that if you pull out a Skittle from an unopened bag, that it's going to be red, or you could express as its equivalent decimal, 0.2. To me, the decimal doesn't quite work here. Like 1 in 5 makes sense, 20% makes sense. 0.2 is a little bit wonkier for me, so I tend to not use the decimals, but you of course are welcome to. Now that's what's called the empirical probability. If you actually opened a bag of Skittles, you could actually figure out based on your bag what the probability of selecting a red Skittle out of that bag would be. And that would be a different type of probability, and we'll get there. Okay, you enter your name in a raffle. If there are 50 names in the raffle altogether, then the probability you win. So this one I can't really abbreviate it because it doesn't really make sense. But what I really care about is if I win, right? That's all. It doesn't matter who else wins, but it does matter if I win. And the probability, if I only buy one raffle ticket and everyone only buys one raffle ticket, then the probability that I win is 1 in 50, which would also be a 2% chance. So there's a 2% chance my name will get selected if there are 50 raffle tickets. Okay, so more definitions. An outcome is the basic possible results of an observation or experiment. In the Skittles example, the possible outcomes were red, purple, yellow, orange, green. And in the raffle, I suppose it would be all of the names of the people who bought raffle tickets. You flip 2 coins, a $50 and a quarter, list the outcomes. When we list the outcomes of these 2 coins, right now, we want to be able to keep track of all of the things that could happen. So what could happen? I could flip a heads on both coins. So I'm going to say $50 here, and I'm going to say quarter here. And I could flip a heads on the $50. I could flip a heads on the quarter. So that one possible outcome is they're both heads. Also, I could flip a heads here, but the quarter could be a tails. Or the $50 could be a tails and the quarter could be a heads, or they could both be tails. And these are the 4 possible things that could happen. We're not including landing on the side. This is you catch it in your hand and put it on the back of your other wrist, and you can't possibly put it sideways on the back of your other wrist. That would be very uncomfortable. But this is it. These are the 4 possibilities that could happen. So we might say the outcomes are that we could flip 2 heads. We could flip 1 head and 1 tails. I don't know why my 1 is so close to the flip. Flip 1 head and 1 tails. Or we could flip 2 tails. And this would be the outcomes. Whoops, I went right over my definition. Next up, we have sample space. Sample space is the set of all possible outcomes in an event where all unique outcomes are listed exactly once. So what I did in my outcomes is I listed what could happen, but not necessarily with order mattering. Like, does it matter whether the $half or the quarter is the one that's a head or a tails, right? It does affect the probability, because the probability of having one of each is 50%, whereas the probability of both is 25% for each one. So when we list that sample space, you might list it in 2 different ways, because whether or not it matters which one is which, that defines the sample space. When we list sample space, we use braces. Braces are the fancy parentheses. If you do shift and then right next to the P, that's going to open up your brace. Below it's called the bracket, right? Very fancy. Good news, if you just do a squiggle, it kind of looks just like a brace. And then we would put the possibilities. Because heads and tails do start with different letters, I can just abbreviate to H and T. And you might want to clarify that, although you probably shouldn't need to, because that should be fairly obvious. But just in case, okay, so I'm going to call heads H and tails T. And then the sample space, we could flip 2 heads, we could flip a heads and a tails, or we could flip a tails and a tails. If the order does matter, then we would put heads tails, comma, tails heads. So that really depends on whether the order matters. So I'm going to say, or if order matters. And this, you would have to make this determination based on the types of questions you're going to be answering. But if the question is just, what's the probability of 2 heads, it would just be 1 out of 4. If the question is exactly 1 heads, then it doesn't matter which one the heads is, right? So that wouldn't matter. But the other option to put the order mattering, we would say HT, TH, and then TT. So you'd have to be really careful about that. And you'll also notice that when order doesn't matter, if we're just listing what could happen, 2 heads, 1 head, no heads, that's also not going to be equivalent to the probabilities, because the probability of each one is not the same as every other one. So notation for sample space, I already did that. That's the fancy braces. That's what we would do for sample space. And that would be that. So then it says the sample space for flipping 2 coins. And again, we have to decide in the context of what you would have to talk to your instructor about which one they want. Do they want just the one where it's, you could just say 2H, 1H, no H, or 2T, 1T, no T, or you would list each one. You'd have to talk to your instructor for that. But that would be what these are, would be my lists of the sample space. Then we have an event. An event consists of 1 or more outcomes that share a property of interest. If E equals event, then the probability of this event occurring is the number of outcomes favorable to E, so the ways E could happen, over all possible outcomes. And this we would say when all outcomes are equally likely. So we would want to be careful with the heads, tails, tails, heads situation. We would count them separately, so that way there's a total of 4 possible outcomes when order matters. The probability of 1 head, so here we go, going back, well, I can just list it. Remember what we had. We had heads, 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 tails, tails, heads, and tails, tails were the 4 combinations. The probability of 1 heads would be these 2 in the middle. There's 2 favorable outcomes out of a total of 4 outcomes, which we could say is 1/2, 1 and 2, or 50%. The probability of a fair 6-sided die. Die is singular for dice, right? That's the number cubes with the dots on them. The probability of a fair 6-sided die landing on 3 is, or we can say P of 3. The probability of a 3 Well, let's see, assuming it says it's a fair die, so it's not loaded, there's nothing weird about it, there's not 5 sides that contain a 3, nothing like that. The possibilities here, if we list the sample space, are 1, 2, 3, 4, 5, and 6. 3, there's one favorable outcome, and that's just 3 itself. So we would say 1 out of, and then there's a total of 6 possibilities. So we could say 1 in 6, or what is this, 12 point, 15 point, I don't know, I'm getting my calculator. 1 divided by 6, 16.7%. That was close. 16.7%. This is why I like fractions, because we don't end up with the repeating decimals or percents, but I know some people don't like fractions, and that's okay too. Then last up, find the probability of a multiple of 3. A multiple of 3, those are the numbers that 3 goes into, where we would say 3 times an integer, and if we get that result, then that's a multiple of 3. So the multiples of 3 in our possibilities are 3 itself, because 3 times 1 is an integer, and 3 times 2 gives us 6. So in this case, we have 2 favorable outcomes to our event, and we have a total of 6 outcomes. That would be 1/3. Or we could say 33.33%, 33.3%, 33.3 repeating percent. Any of those is fine. Okay, so I like breaking from the mold and putting more peculiar rather than the straightforward examples we would normally see. So this is the one I came up with. Let's say there's a family and there's 3 children. One parent can roll their tongue and one cannot. And then according to Google, that means that each child has a 50% chance of being able to roll their tongue, because it's a gene that gets passed down. List all possible outcomes for birth order. So we're going oldest, middle, youngest, who can roll their tongues, and the kids who cannot. We are only interested in the total number of children who can roll their tongues. We're calling that the success. What are the possible events? All right, so we're gonna have our first kid, our second kid, and our third kid. It's just nice to have these organized, otherwise this could get out of control. And now what could happen? Well, because this is kind of weird, I'm gonna say R is that they can roll their tongue. Can roll tongue. And I'm gonna say N is cannot roll their tongue. Okay, so let's look at the possible combinations here for these 3 kids. First up, maybe they can all roll their tongues. That not rolling tongue gene did not come on strong, and all 3 kids can roll their tongue. Well, what else? What about when 2 kids can roll their tongue? Then we have the first and the second, but the third cannot. We could have the first and the second, and the third, but the second cannot. Or we could have the second and the third, and the first cannot. What about when 2 cannot? So the first one could, and then 2 no's. And then we could have the first, can't do that one again, can I? The first one cannot, the second one can, the third cannot, and then N and R. And then lastly, it would be none of them can, right? Then the gene did not come on strong. 1, 2, 3, 4, 5, 6, 7, 8. I do know that in this case, there will be 8 possibilities, because it would be 2 cubed, which is 8, my little shortcut, just to make sure I included everything. Hypothetically, I did not put the same combination twice, right? Like there's only one RRN in that order. Now I put this whole list, but really it's just asking for the events. And the events, in my opinion, would be the number of kids who can roll their tongue. So the events would be 3 kids can roll their tongue, or 2 kids can roll tongue, or 1 kid can roll their tongue. And lastly, 0 of the kids can roll their tongue. So again, depending on the context of the problem, and there is a better way to organize the information here if we're going to be asked questions about probability, but because it asks for the events, and the events are just the things that could happen, those are the 4 things that can happen. 3 can roll their tongue, 2 can roll their tongue, 1 can roll their tongue, none can roll their tongue. When we calculate the probabilities, we assume the experiment is fair, that is, that each outcome is equally likely to occur. So the chance of a coin landing on heads is 50%, or rolling a 3 is 1 in 6, or 16.7%. If an event is certain, then it has a probability of 100%, and we can kind of use this as a guide. Now this is written as decimals, which we know is my least favorite. The equivalent to 0 as a decimal is 0%, that would be 50% in the middle and 100% on the, the absolutely certain going to happen. As a fraction, that would still be 0. This would be 1/2, and this would just go back to being 1. The probability of flipping a coin and it landing on heads or tails, well, that is the entire sample space. There's nothing else that could happen. There's a 100% chance that it's going to land on heads or tails. On the other hand, the probability that it does not land on heads or tails, well, that's impossible. It has to be one or the other. This would have a 0% probability. That cannot happen. And then, when we kind of use this as a guide to help us decide whether something is less likely to occur or more likely to occur. Just a few more things about probability, and then I'll wrap this video up, I promise. Going back to my beautiful picture, the range of probability states that the probability of whatever event, when in fraction or decimal form, must be in between 0 and 1, right? It's impossible or it's certain. We can't go over 100% with probability. Like, there's not a 110% chance that you're going to win the lottery. Actually, that'd be way closer to 0. Maybe you have a negative chance. No, that's also not possible. If there is no chance for an event to occur, then it has a probability of 0. So going back to that bag of Skittles, the probability that you pull out a blue Skittle is 0 because there aren't blue Skittles in those bags of original Skittles. If there is a certainty that A will occur, then it has a probability of 1 or 100%. So the probability of pulling a Skittle that has a color is 100% because there's no such thing as a Skittle with no color. The complement of an event consists of all outcomes in the event in which A does not occur. Note, does not occur. There are 3 different notations for complement, and every book and every single video you watch is going to use different notations, so I'm going to show you all 3. The first one, the one that I prefer, is we say A naught, that is pronounced A naught, and I believe it's spelled A-N-A-U-G-H-T, although I like A-N-O-T because it's like, no, it's like not A. That is not A apostrophe, it looks like an apostrophe or it looks like a little exponent of 1, but it's A naught. We could also do A with like an exponent of C, that means the complement of A. Or lastly, another notation that some books use is like a little line segment on top of A. So if you see any of those 3 in a probability section, know that it's talking about the complement. That's all of the things. So if the event that I'm talking about is a red Skittle, the complement would be the green, purple, yellow, and orange Skittles. It's always true that the probability of A plus the probability of its complement does equal 1 or 100%. So they fill up the entire sample space. They encompass all possibilities. And an example where we might want to use the complement, a bag consists of 40 balls. We have 8 red, 10 yellow, 4 purple, 1 blue, 3 iridescent, 4 polka dotted, 8 green, and 2 orange. What is the probability of not choosing an orange ball? Well, if I'm not going to look at the orange, then I have to add up all of those other numbers. And there were a lot of colors going on this in this bag. So what we could do is we could say, well, there are 2 orange. That would be 2 out of 40. The probability of orange is 2 out of 40, which would mean the probability of not orange, right? Because that's what it's asking, the complement of choosing orange would be 100% or 40 out of 40, right? Because that's the probability of choosing a ball minus the probability of orange, which would be 38 out of 40. You could also not use the fractions, right? You could say, well, there's 2 that are orange, which means 38 are not, and you could do 38 out of 40 that way. We should simplify it just a teeny tiny bit, and we end up with 19 over 20. If you don't like fractions and you converted this, there will be a 95% chance that you will not choose an orange ball. So that's how we could use the complement when talking about probabilities. These have been some basic definitions about probabilities. Thank you for stopping by.